6.5, molecular, also known as covalent compounds. In this section, we're going to learn how to name compounds that are covalent. This set of rules is much easier than the last one. And I will say that in section 6.4, our last one, we're learning about ionic bonding. That, you know what, I don't know about you, but when I learned it, I had to spend a fair amount of time memorizing and then practicing. Well, with covalent compounds, which is this section, it's actually straightforward. You will be able to learn it immediately after watching this video. Now, so then the first thing we need to do is figure out, is it an ionic bond and name it according to the ionic rules, or is it a molecular covalent bonding and name it according to covalent bonding? Well, the way we do is look at the first item in the compound. If it's a metal, then it's going to be an ionic compound and you name it according to ionic rules. Well, the exception to that is if we have the ammonium ion, which because it is an ion in a charge, then it is going to be an ionic bond if the ammonium ion is first. Otherwise, if the first item is a nonmetal, then it's going to be a molecular compound and we're going to name it according to molecular rules. Now, here's a nice flow chart. You don't need to know this flow chart at all. You just need to kind of in your head already know, okay, first thing I have to do is figure out, is it ionic or is it molecular? And at that point, you proceed. All right. Another thing is you have to use the periodic table to help you with naming so that you can figure out, oh, is the first one a metal or a non-metal? And you go, well, what about those metalloids? Well, it just depends. If they're on the non-metal side, like our boron, silicon, our arsenic, or selenium, then we're going to name them as non-metals. If they're on the left-hand side of our stair step, we're going to name them as metals. Now then, molecular compounds form when atoms of two or more non-metals share electrons and form a covalent bond. These valence electrons are shared by non-metal atoms to achieve stability. Notice the thing is shared. The electrons are shared, not transferred. So there's not a charge that's formed. So our molecule forms when two or more atoms share electrons. So in naming, the whole set of naming rules are, here's the first one, so nice, the ending is always "-ide". Always. Not "-ate", not "-ite", not "per-ate", not "hypo-ite", but "-ide". Now isn't that a nice way? The other thing is that we don't have to figure out charges. Why? Because there are no charges. And so because of that, we're going to, though, have to say the little numbers down there that are the little sub. So let's look here. We have to say these numbers here. Why? Because these are being shared, we have to identify which of these compounds it is. And you may go, hold on, back in the last section, you said that NO2 was the nitrite ion. No. NO2 with a -1 charge is the nitrite ion. NO3 with a -1 charge is the nitrate ion. These are not ions. This is the whole shebang. This is the whole compound, NO2. First one's non-metal. That means we have a different set of rules. We're going to name it nitrogen dioxide, nitrogen trioxide. Now we'll notice some of these examples here. Now, on table 6.11, carbon dioxide, carbon disulfide, dinitrogen. This should be monoxide. I can't go in there and change this table, but normally we name it this way in the higher chemistries. Same thing here, nitrogen monoxide. If the second one is just one, usually it's mon. Okay? The first one, if the first one's just one, we're not going to say mononitrogen monoxide. We're going to just say nitrogen monoxide. So sulfur dioxide, sulfur hexafluoride, sulfur trioxide. So let's name the molecular compound NBr3. Well, N is a nonmetal, so we're going to name it nitrogen. And our bromine, when it becomes the end of our compound, we're going to change the ending to "-ide", but we got to say these little numbers down here because you know what? There could be different combinations of these two items. So we're going to call it nitrogen tribromide. Now then select the correct name for each molecular compound. Okay, Si, because the first one's a nonmetal, we name it according to the nonmetal rules, which is the ending is "ide," and we say these little numbers down here. So silicon tetrachloride. Okay, now then P is a nonmetal, so that means we just end the ending in "ide," and we're going to say the numbers down here. Diphosphorus, and then our 5, the pentagon has 5 sides, okay, so pentoxide. Now we have our chlorine, so it's dichlorine. Okay, now 7 is heptoxide. Now press pause and write the name for each molecular compound. Now notice CO, carbon monoxide. Oops, sorry. Dinitrogen monoxide. Phosphorus trifluoride. Carbon tetrachloride. Press pause and write the formula for diphosphorus pentoxide. So here we go. Diphosphorus pentoxide. Press pause and write the correct formula for each of the following. Now, let's look. We have phosphorus pentachloride, so P is phosphorus, and then penta means 5, so we have 5 of our chloride atoms there. So phosphorus pentachloride. Dinitrogen trioxide, N2O3. Sulfur hexafluoride, SF6. Okay, now then, let's look at this. We're going to combine all of the learning that we've done in the past 2 sections here. You first have to identify if it's an ionic or molecular, i.e. covalent compound. Then you can then give the correct name. So press pause and come on back. All right, we're back, and I got a drink of water. So the first one is a non-metal, so it's molecular, so that means our ending is "ide," and we're going to say sulfur trioxide. Okay, barium. You check and see, oh, that's a metal. Okay, then we're going to name it as an ion. That means we just say barium chloride. We don't say the little numbers down here because of the fact that because it's held together by charges, it can only be one possible combination there. All right, C. Ooh, I recognize this as the ammonium ion, and I recognize this as related to phosphate, but it's one less oxygen, so it's going to be phosphite. So ammonium phosphite. Okay, here we go with copper. Now, copper is one of those metals that can be more than one charge, so we got to figure it out. Okay, so first of all, I just said metal, so that means we're going to name it according to ionic naming. And this copper is one of those 4 that I said you had to memorize that can be more than one charge. So because it can be more than one charge, we have to use a Roman numeral. And you go, well, what charge is it? Well, our carbonate is a -2 charge. This is we've got 2, so 2 times what charge is going to give us 2? Oh, well, that's 1. So this is going to be copper 1 carbonate. Now this first one is a non-metal, so that means we're going to have to use our molecular endings. And so we're going to have to say the little numbers down here, and our ending is "ide." So dinitrogen tetroxide.